about proportions. They are also called direct variations. I like proportions better, but if you see something on the STAR test that talks about a direct variation, it's the exact same thing as a proportion. All right, does anybody know what a proportion is? By the way, this one right here was a proportion. Bella.
It's like you find out the missing numbers. If you do a percent, you put like the number was over 100, and then you put the number there, and then you multiply it, and then divide, and that's the number that you want.
Okay, I'm going to give partial credit on that. Did you hear her say the missing number?
Yeah.
We'll talk more about that missing number in just a minute. Ledesma?
Usually if you graph a proportion, it goes in a straight line up, or a straight line down.
And?
And it always is...
Goes through the...
Oh, the origin.
There you go. Nice. Lizzie, you got anything to add? No. Okay. All right, y'all actually gave me a pretty good start to the notes. A proportion does two things. One, it makes a straight line when we graph it. And to make the straight line, it must have what's called a constant of proportionality. It's a big word. And two, it must go through the origin. Where's the origin?
0, 0.
0, 0. So if we can find a equation or a graph that does both of those, we can say that it is a proportion, without a doubt. Can anybody prove that this one goes through the origin? Layla?
Have all the numbers are like evenly spread out.
They're going up by what?
10.
10. So use that to your advantage. If we're adding 10, how can we prove that it goes through the origin 0, 0? Ledesma?
X times 10 equals y, so if you put 0 instead of x, 0 times 10 always is 0, so it could equal 0.
Okay, I'll take that. There's an easier way.
Because if you go backward,
Thank you.
it would be 0, and then if you go back on the y-axis, the 10, it's also going to be 0.
Y'all agree with her?
Yeah.
Both of them just proved it. Hers is a little easier to see. Does that make sense? We'll talk more about yours in a minute. But y'all agree with Bella? Oh, we're adding 10. If we go backwards and subtract 10, wouldn't we get 0 here?
Yeah.
And these are going up by 1. If I go backwards and subtract 1, wouldn't it also go to 0? So doesn't it go through the origin 0, 0? That's another way you can find out if something is a proportion pretty easily. All right, any questions so far? Now, the equation for any direct variation or proportion is y equals k times x, right? K is what we call the constant of proportionality. And I usually don't write out all of that. I just call it the constant. K is the magic number. Can anybody tell me what K is in this first example on the warm-up? You've already helped me. Thank you. You've already helped me. Thank you. Somebody knew. What number do you think K would be in this problem? Ethan, take a guess.
1.
Nope, K would not be 1. That would be X. Caden, 10 is the constant of proportionality because it's going up by 10 every time. Are you with me? So in that problem, here would be the equation for number 1 on the warm-up. Y equals 10x. And did you hear Ledesma earlier say, Well, 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30. She said 10 times 0
Zero.
is 0. So she proved it goes through 0, 0 by using the equation. Are you with me? Both of them were right, by the way. All right. What if we didn't know what K was? Let me give you a point. What if they just gave me the point 315 and they wanted me to find the K? You've already helped me, ladies. You're done. How could I find, you've already helped me, Lizzie.
No, I haven't.
On the warm-up, yes, you did. How, oh no, you didn't, I asked you, but you didn't have anything to offer. So what do you got?
I was gonna say you divide
Divide what?
15 by 3.
Very nice. What is 15 divided by 3?
5.
Lizzie just found out what K is. What is K?
5.
5. So what would be the equation?
Y equals 5.
Y equals 5 times X. Very nice. Now, what Lizzie just did works all the time. If they ever ask you to find K, all you gotta do is divide the Y number by the X number. So let's write that down. That's probably the most important piece of the notes today. If you ever want to know what number K is, this never fails. Put a star by it. K is always equal to the Y number divided by the X number when we're doing a proportion. And did y'all notice when I was explaining this, didn't I say what's 15 divided by 1?
Mm-hmm.
What's 30 divided by 2? 45 divided by 3? What was I doing? Dividing the Y by the X, which is exactly what Lizzie just told me to do to get the K here. Questions? All right, let's look at some problems that you might see today. They might give you a table and ask you, is it a proportion? How could I look at that table and tell pretty quickly if it is or it isn't a proportion? You've already helped me. You've already helped me. You've already helped me. You've already helped me. Somebody know. Oh, I get to pick. Let's go with Haley. How could I tell if this is a proportion or not? Good answer. Dividing what? Good. What's 12 divided by 3?
4.
4. So does that mean it's automatically a proportion if the first one?
No.
Let's go to the next one. What's 18 divided by 6?
3.
3. Is that the same number?
No.
Is this going to be a proportion?
No.
No, it's not. When I divide the Y by the X, the Y by the X, if I get the same number every time, that is a proportion. If I get a different number, it is not a proportion. Are you with me? All right, good. Ooh, it's not a very good 9. Is this a proportion?
Yes.
Anybody else? Somebody know? Marcella? You say yes? Prove it. Does it go through the origin? Check. Now prove that it has a constant of proportionality. Is 3. And what's 9 divided by 3? 3. Do y'all agree that every time we divide the Y by the X, we get the same number every time?
Yes.
What is the equation for this problem? Who can tell me the equation? Haley.
Y equals 3x.
Very nice. Any questions on that one? All right, good. So if they give us a table, they're pretty easy to tell if it's a proportion or not. What if they give me a graph? like this and say, if you've already helped me, don't raise your hand, girls. Is this graph a proportion or not? Emma, what do you think?
No.
You say no, prove it.
It doesn't come to the order.
Do y'all agree with Emma? I agree with Emma too. This graph, it is a straight line, isn't it? But it does not go through the origin, 0, 0. It would have to go through right there to be a proportion. But it is a straight line, so no, that is not a proportion. Very nice, Emma. What about this one? Would that one be a proportion? Hammock. Yes, it is a straight line, and it goes through the origin 0, 0. That one would be a yes. Questions. All right. And then what if they did this? This is the one on the homework that messes up people. Let's see if it messes y'all up. They tell us this problem is a proportion. Find the missing value. So they do tell me it is a proportion. We need to find out what number is missing right here. And Hinesley,
9
how did you get that?
is 2 divided by 18 is 9.
Okay, I agree with, how about 18 divided by 2? Is that what you meant to say?
Yeah.
18 divided by 2 is 9. So do y'all agree that K in this problem is 9? Okay, so what do we need to do over here? We got to do something with that. So what number would we need here? He said 9. I'm going to slightly disagree with 9.
You need to do y equals k times x. So,
Well, we know what K is.
so you need to do 9 divided by 72.
You mean 72 divided by 9?
Yes.
Yeah, what is 72 divided by 9?
8.
8. Are you with it?
Mm-hmm.
So here, the missing number is 8, and let me prove it to you. Isn't the K 9? 9 times what makes 72? 8. You were close. You needed to divide by 9 to get to 8. 8 was the missing number. So they could give you something like that. And if they do that, they have to tell you that it is a proportion, or we can't figure out what number goes there. Does that make sense? All right, let's see if there's anything else. No, we're good. All right, we're ready for the homework.